This problem is all about squares. Using a construction kit with 12 straight rods and 9 connectors in the corners, we can make this design. It has 4 small squares and 1 larger outer square, and so it contains 5 squares altogether. We could break all the squares by removing just 3 rods. Here's one way that could be done. Now, here's a larger design with a greater number of squares. How many squares of all sizes does it contain? And what's the smallest number of rods that need to be removed so that all of the squares are broken? Explain your answer.
You only need to remove 1 rod to break apart any size of square.
Think about how many different sizes of squares you can find.
Bear in mind that squares can overlap each other.
Ours is fun.
Give it your best effort.
To work out how many squares were in the model, let's look at how we got our answer. If we start counting the smallest squares, there are 9. 4 medium-sized squares and 1 outer square. So 9 plus 4 plus 1 gives us 14 squares in all. And for the second part, what was the smallest number of rods that need to be removed so that all the possible squares are broken? There are a few ways you could go about this. You could break the squares in order of their different sizes, starting with the biggest square around the outside. Another way would be to pick a corner and work your way around the squares from there. To break all 14 squares, 6 rods need to be removed. This solution is just one way of solving it. Have you found any others? How does that relate to these ones over here? Great job if you made a breakthrough with this challenge.